All right, so this is 8.6, dilations. A dilation is a transformation where the image is either larger or smaller than the pre-image. The stop sign would be in the middle. I go smaller to get to here, and I get bigger to go to here. The dilation. When we go bigger, it's called an enlargement. When we make it smaller, we call it a reduction. So let's recover scalar multiplication. When we do scalar multiplication of matrices, we take any number and we multiply it by each element in the matrix. So, for example, 8.25, here I'm doing scalar multiplication. I'm going to take this 3 and times it by every piece in the matrix. So times by -5 gives me -15. Times by -4 gives me -12, and so on. We just multiply it by each and every piece of the matrix. This is how we perform scalar multiplication. We're going to use this to perform dilations, okay? So be very comfortable with how to do this. This next example, fractions. We can do fractions very nice and easy. I'd recommend that you get with me on your own time, and we can discuss how to do fractions. But for right now, I'm going to do the best I can to do a very generic example of how this works. Okay, if I take 9 and I times it by a fraction of, let's say, 5/3, okay, I have two choices. One choice, I'm going to do it in blue, is I can multiply the top and get 45 and divide that by 3. That gets me 15. So I multiply, oh goodness, okay, that went way too much. 45 divided by 3 equals 15. Okay, so I can either multiply first and then divide to get my answer, or it's smarter if you divide first and then multiply. So 9 divided by 3 gets me 3, then I multiply it by 5, and I end up with 15. So I like to divide first and then do my multiplications second. So using this principle over here, I'm going to erase it real fast. We're going to use that a bunch of times on each one of these multiplications. Remember, I told you it's easier to divide first and then multiply. So if I divided all of these by 3, okay, 12 divided by 3, 18 divided by 3, I divide each one of them by 3 one at a time. 4. Remember, I divide first and then I multiply. I'm dividing each one of these by 3. And now I'm going to multiply each of them by -1. And I end up with -4, 7, -6, -10, 2, 5. However you do your multiplication of fractions, okay, is up to you. But regardless, we need to know how to multiply 1/3 times any number we want. All right, moving on. Dilations. Every dilation has a center of dilation. It has an original figure and it has the dilated figure. In this case, we are doing an enlargement. All right, now enlargements have a scale factor of larger than 1. Notice here I say CP prime. Well, that's this big 5. That's C, the center to the new shape is 5. And the center to the old shape is 2. So the scale factor is 5/2. For a reduction, it's smaller than 1. Which makes sense. If we want to make something smaller, we got to make it smaller than 1. So we take our new shape is 3. Our old distance was 6, and so we do 3/6. We reduce it. Our scale factor is 1/2. All right, so now let's look here. What is the scale factor? Well, I find my original is 12, and my new one is 4. So we do 4/12, and we reduce. Remember, CA prime over CA. This is kind of the formula for a center of dilation. Now, if we look here, we're going to use, is it an enlargement or a reduction? Oh, our scale factor is 1/3. That's smaller than 1, so that makes it a reduction. Remember, when your scale factor is less than 1, it's a reduction. All right, so now let's use this information to solve for x. Since our scale factor is 1 to 3, remember 1 to 3, we set that equal to x over 8. We set up the ratio. Scale factor 1, or we could even done 4 to 12 if you wanted to, but we could do 1 to 3 and x to 8. 1's on top because it's part of the smaller piece. X is on top because it's part of the smaller piece. Now we go ahead and we cross multiply, giving us 1 times 8 and 3 times x. And when we do that, we end up with dividing both sides by 3 to get 8/3. So the value of x, not the scale factor, but the value of x is 8/3 long. Okay, there we go. Your essential question, is a dilation an isometry? Explain. Okay, we know an isometry is a rigid transformation. It preserves lengths and angles and shapes. So is a dilation an isometry? Does it preserve length? Dilations. All right, we're going to use matrices. Oh my goodness. All right, so we can use the scalar multiplication of matrices to help us do dilations. So if we plot our points, here's A, B, C. Let's go ahead and plot those on our notes. Okay. Now, if I then ask you to find a scale factor of 3, okay, our scale factor is 3. We've got our triangle, and I want to do a scale factor of 3. Now, again, your center of dilation is always going to be the origin, but I'm going to take it, I'm going to set up in a matrix. So I've got now A, B, and C are set up as a matrix, and I scale multiply everything by 3. Watch what happens. Okay, I just times everything in here by 3. Now here, that's my dilated image. I now have the matrix for the new shape. I take that and I plot each point. 9, 18. Negative 9, 12. 15, negative 9. Look at that. I'm done. All I had to do was set up a matrix, multiply everything by my scale factor, and plot the points, and I was done. Now, if I wanted to check my answer, I could take a ruler, and I could draw a line through the 2 endpoints of each piece, and notice that they all intersect at the origin. That's a great way to check your work. Okay. I would recommend checking your work each time to make sure it makes sense. Okay, so for this activity, if you have a compass where you're at, wherever you are, follow along. If not, just follow what I'm doing. We did this at the beginning of the year, so I'm not too worried about it, okay? So if I have to dilate with a scale factor of 2 from the point T, I draw with a ruler to each endpoint. Notice how I extended these ruler lines all the way out? Okay. When I do that, this is what you should have. Now we're gonna set down the ruler, and we're gonna now use our compass, the pointy part at the center of dilation. We measure it and we lock it in place for this long, and then we move our pointy thing to that point, and we draw a little arc, and we'll do it again here to make it easy. Now we do pointy thing and the pencil here. Move it, make an arc. Move it, make an arc. The same thing here. Now we got to open it all the way wide, and we touch it to here and here, and then we move it, make an arc, move it, and make an arc. The arc is really just to find the intersection points. Okay. Same process here. We put the pointy tip. We measure how big it is from the center of rotation to the endpoint. We move it, make an arc, move it, make an arc, and now we can start connecting some dots. Notice how this is the first arc on this length, and this is the first arc on this length. And then we do firsts and firsts and firsts. Now we do seconds. Okay, we connect all the second marks together. And now we've got a dilation with a scale factor of 2 is the blue one, and a scale factor of 3 is the red one. And that's really, really nice way to construct a dilation. Now this part is going back to what we started out on the first place, okay? To do example 8.29, we're going to first blow up a problem or make it bigger, and then we're going to reduce it down by half. So again, we draw our lines, we double the size. Now I want to point this out right here. You do not use this intersection, you got to go to the end point of the shape right here. Now double it and double it. All right, connect our shapes. Here is our new triangle. So we just doubled the size of the old triangle. I'm going to pull out the notes so I can make sure you're doing what I want you to be doing. Okay, so right down here where we just made R bigger. Okay. Now we just blew it up big, and now we're going to look at how to make it smaller. To do this, we're going to use what's called a perpendicular bisector. I believe you guys used to call this the archy thing, the half circle thing. Remember how we would do a pointy thing here, draw an arc, pointy thing here, draw an arc, and then we'd get this little eye shape. That was from the beginning of the year. When you get that little eye shape, you connect those two endpoints, and you make a little mark right here. This little mark is halfway between the two endpoints, R and the endpoint of the triangle. Now we're going to do it again. Don't use that endpoint. You got to go all the way across. Make sure you're big enough. So now we go arc, arc. Notice here's my eye shape that I'm using. Right here, eye shape. And then I find my intersection between those 2 points, and there's my intersection. Now I come over here and I do another arc, arc. I get my eye shape again. Remember this little half eye closed shape? Then I connect with my ruler these two endpoints where they intersect, and then I draw my little line. Now each of the red lines there, each of these little red marks, is halfway between the big triangle's endpoints and R. So when I connect them as a triangle, I've now created a triangle that is half as big. Now most of this we covered at the beginning of the year, so I'm not going to take a lot of time on this, but you should be able to construct perpendicular bisectors, or the half circle-y things, and the eye shapes just fine. Okay, do not erase your extra marks. That's you showing your work. Please summarize what you learned about as far as dilations go. And then look at the calendar. Tomorrow we're doing a composition activity, and then the test is on Friday. Okay, so a little preparation for the test. Okay, you've got 5 problems. They're worth 19 points. Okay, first one is to translate a polygon. You're going to have to do that. Graph it, give me the matrix, graph the new shape. That's 3 points. Then we have to do it for a reflection. Again, graph it, give me the matrix, and then give me the graph of the image. 3 points. Rotate. You're going to have to do rotations. Again, graph the pre-image, graph the image, and complete your image matrix. Those are all 3 points. You're going to have to do a dilation on your page. You're going to have to do a dilation. 3 points. The last one is what's called a composition, where we do more than just one. So if I start out with PQRS, I translate it there, 1 point. And then I write the matrix. That's another point. And then looks like here I translate it up. And then it looks like a rotation. So I rotate it over to here. That's another point. And then I reflect it down over the x-axis. And right here, there's another point. This is just one example of where I take a shape and I keep moving that shape until I get down to here. What you'll have to do is you'll have to do 3 different matrices and 4 different graphs for this one problem. It's worth 7 points, so don't be confused. Tomorrow we're going to work on that a lot. But when you come in, you've got to do a translation, a reflection, a rotation, a dilation, and then we're going to put them all together into one big problem. Now on your homework tonight, you've got 3 of each kind of problem to help you get ready for tomorrow. Please do your homework. Make sure you've got it ready for tomorrow. Hope this video helped. If you have questions, please come see me.